Hey everyone, and welcome to today's Explainer. Today we're taking on probably the most ubiquitous force in modern technology, the cloud. And we're going to break it down into a concrete, understandable system. We all know our data is floating around in it, and our businesses literally run on it. But by the end of this Explainer, you're going to see right past the interface and really understand the invisible engine that's powering the modern internet.
To kick things off, picture this nightmare scenario. You're walking down the street, you trip, and your smartphone slips right out of your hand and shatters into a million pieces, just completely destroyed. Now, 10 years ago, that meant you lost everything. Your photos, your contacts, all those messages. Just poof, gone. But today you just buy a new phone, log in, and like absolute magic, every single photo, video, and conversation is sitting right there waiting for you. Why? Because your digital life doesn't actually live on that little piece of glass and metal in your pocket anymore. It lives in the cloud. Okay, let's dive into this. Here is our roadmap for today. We're going to start by decoding the cloud, look at its evolution, and then get right under the hood with how the cloud actually works. From there, we'll unpack the different cloud service models, explore public, private, and hybrid environments, and finally, take a look at the future of computing. Let's get right to it.
Section 1. Decoding the cloud. Let's look behind the scenes. So, instead of storing heavy databases or running really complex software locally on your laptop or your phone, you're basically just using the internet to access centralized servers. And those servers, they're sitting in massive data centers somewhere in the world, doing absolutely all of the heavy lifting. The actual location of the physical hardware is entirely invisible to you, the user. You just open a browser or tap an app, and all that computing power is delivered to you instantly over the network. Now, to really appreciate this, we kind of have to contrast it with how things used to be done. In the past, with on-premise IT, a business had to buy, install, and constantly maintain a room full of incredibly expensive physical servers. They were paying for the power, the massive cooling systems, the IT staff to patch the software, and if a server broke, totally their problem. But with cloud computing, a vendor, think Amazon, Microsoft, or Google, they own and maintain all that hardware. You simply rent the exact computing power you need exactly when you need it, and you only pay for what you actually use. It literally removes the whole headache of infrastructure management. Moving on to Section 2, the evolution of the cloud, which was actually decades in the making. You see, the modern cloud didn't just pop up out of nowhere. It's the culmination of decades of massive technological leaps. Back in the 1950s, we had these huge, centralized mainframe computers where multiple users would connect via really basic terminals. Fast forward to the 1990s, and we see the rise of grid computing, where distributed computers across different networks started working together on big problems. But the real game changer hit in the 2000s with hardware virtualization. That technology let us maximize server efficiency in ways we'd never seen before, and that directly birthed the modern cloud computing ecosystem that we all rely on today. I absolutely love this quote from our source material because it just hits the nail on the head with the perfect metaphor. Think about it. 100 years ago, a factory had to literally build and run its own private power plant just to keep the lights on. But once a reliable public electricity grid was built, it became infinitely cheaper and easier to just plug into the wall and pay for the electricity they actually consumed. That is exactly what the cloud is doing to IT. Computing has simply become an on-demand public utility. It's just like turning on the tap for water. Section 3. How the cloud works. Let's look at the invisible magic. Okay, so the secret sauce making all this happen is something called hardware virtualization. In a traditional setup, a physical server often runs at just 10 to 20% capacity because it's only dedicated to one single application, which is incredibly wasteful. Virtualization solves this by using a piece of software called a hypervisor. We're talking technologies like VMware, Xen, or KVM. This hypervisor sits right there directly on the hardware and basically tricks that one physical machine into acting like a dozen completely separate virtual machines. Each of those virtual machines can run its own operating system and its own apps without interfering with the others. It maximizes efficiency and makes allocating resources across the internet insanely fast. But the magic really goes to the next level within the backend server network. We just talked about virtualizing one server, right? Well, the cloud is made up of thousands of these servers working together. Because data is essentially the lifeblood of cloud computing, this whole backend network relies heavily on redundancy. When you save a file to the cloud, it isn't just sitting on one solitary hard drive. The central administration system is constantly backing up your data across multiple locations and servers within this massive farm.
So not only does this astoundingly increase the available storage capacity, but it also means if one piece of hardware completely fries, no worries, your data is still perfectly safe and instantly accessible from another server. Section 4. Cloud Service Models. We're going to look at the 3 layers. The really crucial point to grasp here is that the cloud isn't just one monolithic thing. It's built in 3 distinct layers, kind of like a giant cake. You have the user devices on the outside interacting with the application layer at the very top. Right beneath that, providing the foundation for those applications to run, is the platform layer. And then at the bedrock, managing all the raw computing power and storage, is the infrastructure layer. Let's break down exactly what each of these means for the user. So these layers represent the 3 main service models of the cloud. Right up at the top is software as a service, or SaaS. This is the stuff you use every single day, things like Gmail or Salesforce. The vendor manages the whole shebang. You literally just log in through a browser and use the app. Next level down is Platform as a Service, or PaaS. This one is really for the developers. It gives them a ready-made environment to build and test their own software without having to worry about setting up or managing the underlying servers. Finally, at the base, we have Infrastructure as a Service, or IaaS. This is the raw engine room. Services like Amazon EC2 give businesses total, hands-on control over virtual servers, storage, and networking on demand. Really, the main difference between these 3 is simply a matter of how much control you want versus how much you want the vendor to handle for you. Moving to Section 5, Public, Private, and Hybrid Environments. When a company decides to make the jump to the cloud, they have to choose an environment. On one side, we have public clouds. These are owned by third-party vendors and shared among many different customers over the public internet. They're incredibly affordable and highly scalable, but because you're sharing infrastructure, some organizations get a little nervous about strict security and privacy. On the other side, we have private clouds. These reside entirely within a single organization's internal network. They're highly automated, give you total control, and offer absolute top-tier security. The catch? Well, the organization has to invest really heavily in buying, building, and maintaining all that infrastructure themselves. But what if a company wants the best of both worlds? That, my friends, is where the hybrid cloud comes in. It's a customized architecture that beautifully links a company's secure internal private cloud directly with a highly scalable external public cloud. So think of a bank, for example. They can keep their highly sensitive customer financial data locked down tight in their private cloud, but at the same time, they can use the cheap, limitless computing power of the public cloud to run their customer-facing web apps. It basically lets organizations perfectly maximize both security and scalability based exactly on what they need. Section 6, the future of computing. We're talking about a complete paradigm shift. All of this incredible architecture builds into core advantages that are completely reshaping the modern business world. The shift to the cloud provides massive cost reductions because businesses just don't need to sink huge amounts of capital into physical hardware anymore. It offers lightning-fast speed, allowing companies to spin up and deploy new servers globally in literally minutes, not months. It offers limitless scalability, meaning computing power can dynamically grow or shrink on demand to meet sudden traffic spikes. And through that redundancy we discussed earlier, it delivers rock-solid reliability with absolute minimal downtime. It really is a total paradigm shift in efficiency. Which leaves us with a truly fascinating question from our source material. Are we actually witnessing the end of desktop computing? As our internet connections get faster and the cloud gets exponentially more powerful, there is just less and less reason to rely on local hardware and local operating systems. We're rapidly entering this new web-based service economy where the actual terminal sitting right in front of you matters far less than the invisible infrastructure it connects to. It could very well be the beginning of the end for traditional desktop dominance. Thank you so much for hanging out with me on this deep dive into the cloud. I hope it brought this somewhat nebulous topic into really sharp focus for you. Keep learning, keep exploring, and definitely stay curious.